as we all know, that Stephen Hawking is no more in this world, but still he is alive in his theories, and he would remain alive in his theories forever and ever. Well, he was a star. He came here as a star, he lived here as a star, and he went back to the star. He was really a superstar of physics. Stephen Hawking helped us to understand universe and black hole in a simplest way. Well, we all know his contributions to the world of physics. And no one can forget the book called as Brief History of Time, as you can see from here. This book is a bestseller of the year, and it is a wonderful book in which you can understand black holes. In fact, anybody can understand black holes by reading this book. It was really a great work done by Stephen Hawking, the great physicist of all time since Einstein Newton. Today, I am here to pay a tribute to that wonderful physicist, the greatest physicist, Stephen Hawking, and for that reason, I am going to explain you some concepts of black holes and Hawking's radiation, which was published by Stephen Hawking. Well, friends, today, whatever I will tell you, whatever I will explain you, I would like to give credit to this book, because this book really helped me to understand the basic concept of black holes and the universe. Today, I will tell you about black hole first. Now, first, the thing is that what is black hole? Black hole is a region of space and time from where nothing, not even light, can escape. The gravitational field of black hole is so huge, is so intense, or the intensity of gravitational field is so great, is actually very huge. Due to that reason, nothing, not even light, can escape from it. Due to that reason, it is called as black hole, and we can't see anything in that hole. You can say whatever particles or might be any kind of object going inside a black hole is totally lost to the external observer. That means we can't be able to see after any object after it enters the event horizon. Now, what is event horizon? Black hole has two parts. One is singularity and another one is event horizon. Event horizon is a boundary, you can say, and once you cross the boundary, that means you are in a black hole and you cannot be able to come out from there. That is called the event horizon. Now, I will explain you Hawking's radiation. What is Hawking's radiation? Actually, black holes also emit some radiations. The question which is coming out of mind, that black hole, that nothing, not even light, can escape from black hole. Then how can we get radiations from black hole? Well, Hawking explained this fact. He told that there are virtual particles and there are particle-antiparticle pairs. We can say virtual particles. One of the pair, or one of the particles from the pair is attracted by the black hole, and the other particle is emitted by the black hole. And it is this particle, not emission, it's actually you can say one particle is attracted by the black hole, another particle, you can say, suffers a repulsion for the black hole. And it is this particle which we interpret as radiation. The emission of this particle from the event horizon is called as Hawking's radiation. Now, what are virtual particles? For understanding virtual particles, we have to study quantum field theory. Well, I have one book from quantum field theory, as you can see. Once you go through the book, you can understand what exactly a virtual particle is. Today, I don't want to go through the virtual particle because it will take a huge time to explain about the concept of virtual particle. Rather, I will just want to explain you simply the meaning of black hole. We have to understand it in a simplest way. Suppose there is a space. You place an object in the space. It will get curved. Gravity is just the effect of this curved space. And this theory was published by Albert Einstein. And we can understand about the effects of gravity, or the way how gravity works, from his theory of relativity. Now let us tell you something more about this. Suppose the mass becomes so huge in the space that the curvature increases, and a time will come when the space-time will totally carved in the way, in such a way that not even light can escape from it, and then we get a black hole. Now, how black hole is formed? There is a question. How it is formed? Actually, it is formed when a star dies out. When a star dies, When a star, or in a star, when a star collapses in its own gravitational field, it results in the formation of singularity, and that singularity is actually nothing but just black hole. Now the question is coming to our mind is that before Big Bang, I think the entire universe was at a singular point, or you can say it started from singularity. What is the difference between that singularity and the singularity of black hole? Well, the singularity of black hole is surrounded, or you can say enclosed by an event horizon, a boundary from which if you will cross the boundary, you can't be able to get out from it. But a Big Bang, but a singularity from which our universe started was a naked singularity. That is the basic difference between these two singularities. So don't get confused with the two singularities. They are completely different. One is called a singularity, which is surrounded by event horizon. Another one is a naked singularity, which is not covered or surrounded by an event horizon. Now, information loss paradox. What is information loss paradox? Whatever, suppose my name is Rajkumar. Okay. Suppose somehow I cross the event horizon. All of my information, that what I am, who I am, will be lost to the external observer. That means they can't be able to extract the information from the black hole. That what is going inside, what is going outside, what is going inside. So once you will cross the event horizon, the information of that particle, of that object, is totally lost to the external observer. And also one more thing I'm going to tell you, that inside black hole, time is constant. Well, in order to explain this fact, I have to go through time dilation. But today, it's actually today the day when Hawkins died, so I just have taken an initiative to explain few facts about Hawkins radiation and also black hole. And I won't describe anything more because it will take huge time. So today, let us pay a tribute to the famous physicist of all time called Stephen Hawkins. And we all know this book, Brief History of Time. It is the same book which is published by Hawkins, and it was the bestseller of the time. It's really a wonderful book. So I would like all of you to read this book, as if you read this book, you can understand the theories of Hawking, or you can say black hole, which he really explained. He had really sacrificed his entire life in order to understand the universe, the way, how it works, how black hole works, what is black hole, why it is there. He really had given lots and answers to all of these questions. Thank you very much, and we will never be able to forget his contributions to the world of physics. Thank you.